Okay, here we go. Taking the first derivative of this. Okay, the first derivative of this would be cosine of 2x minus pi over 3 times 2. Okay, and then since there's a pi here, you stick it in. 2 pi minus pi over 3 is 6 pi over 3 minus 1 pi over 3 is 5 pi over 3. So the cosine of 5 pi over 3 times 2. Well, the cosine of 5 pi over 3 is positive 1/2 times 2, which is 1.
Let's see if it works in the calculator.
Okay. All right. The first derivative of this is the same as saying the first derivative of 3 cosine of x cubed, all with the 1/2 power around it. So we have the chain rule again on this one. So this is 1/2 times 3 cosine of x cubed to the negative 1/2. All of that to the, 1/2 out in front, that, and this is to the negative 1/2 times the first derivative of the inside, which is 9 cosine of x squared, times the first derivative of the inside of that, which is negative sine of x. The chain rule, actually, on that one.
It's probably B. Is it B?
Okay, so 2 is on the bottom. Square root of 3 cosine cubed of x is on the bottom. On the top, negative 9 cosine squared of x sine of x.
My mouth is watering.
Literally, it's B.
It's every time.
Okay?
Guys, just go biggest answer.
Okay. I would do it this way for this one. Okay, I would take the negative 2 up to the top. I think most of you would too. Negative 2x, negative 12x to the third, negative third, right? And then take the derivative of that, which would be 36x to the negative fourth, which would be 36 over x to the fourth. Wow, same question twice in a row, so we'll skip that one. All right, this one, f of h of x. So then, are we doing inverses here? No, this is not an inverse. Oh, it is. It's the first derivative of g, which is f of h of x. So you go to h of x. Okay, so at 2, you go to the h of x. It's negative 1. So you go to negative 1 and you go to that one, right? Negative 6. No, you're thinking inverse, which is 1 over that answer.
Yeah, you have the times that the H and H.
Oh, I did H and H, didn't I?
You good, man. It's the same answer, right?
It's still negative 6.
How?
Because you're multiplying by
Because it's, yeah, this is composite functions. This is Trey.
Michael, I'm trying to go to teachers. What did he say? He said no. He said he can't today. So
All right. So g prime of 2 is, okay, let me rethink this. It's f of h prime of 6, right? Or at h prime of 2. So
Shouldn't it be F
No,
prime of
no.
H of H?
It's f prime of h of 2. That's what it is. F prime of h of 2. So you go 2 to get to negative 1. You get negative 1. F prime of that would be negative 5.
Times it by 6.
Guys,
What's
we're
the answer?
overthinking this.
I feel like it's -6, dog. I think it's -6. But Steve, if you have -5, then you have to take it times the h of 1.
Yeah,
or
You
whatever.
don't take it
You do
times.
the diagonal.
I'm telling
do
you,
the
I
diagonal.
remember getting this
What's
wrong
the
like
diagonal?
50
Which one
times.
is it? Taking the first derivative of F of H, not times H.
Oh, sorry.
Still have to take it times the first derivative.
Yeah, it's the diagonal one.
I'm telling you, Steve.
It is a diagonal one, but
Which one is it? Which one is it?
okay. I don't know.
It's either -6 or negative.
I don't have the answers on me for this. So sorry. Assign.
Steve, I'm telling you, you gotta multiply, bro.
It's
Whatever
not-
you're
I can
thinking,
promise
you're
you it's not
wrong
negative
for once.
6.
I'm telling you.
I promise you it's not
It's either
negative
-6. It's either -6 or -30. One of them.
I can tell you it's neither of those.
I'm
I
telling you,
guarantee
you're
it
wrong.
is.
Steve is
Steve
wrong.
is wrong.
Steve is
Steve
wrong.
is wrong.
Dude, Steve's wrong for the first time ever in his life.
Steve is wrong. Steve's wrong.
Bro, I got none of these.
I can't
Hero,
imagine how
what do you
Steve
think it is?
feels. We're just making fun of him. We're gonna do this the first time he's ever gotten a question wrong.
There we go. Chain rule of tables. There we go. Okay, chain rule of tables. It's this one right here.
No.
Oh. Well, it doesn't matter. Let's just go here and see what problem they throw at us. Okay, let's look at this one. No, it isn't because it's a -2. Okay. Yeah, but I understand what you're saying, Choni. We're good. We're good. Okay, so g of -2. So at -2, you go across to the g function. You get 1. So then you go down to 1, and you go all the way across to the f function, which is 4.
16.
So they're saying 16 over here because it's 4 times 4. Because it's this one here, the outside prime times this one here. Let's do another one. Next question. Okay. So at -1, the inside h of x.
It's 24. Put it in, dude.
Just no. Whoa.
No, it's not.
Yes, it is.
It's 16.
It's 24. Yeah, it is. Where did you get
Negative
16?
I can't read the board. What is that?
No,
number?
low-key is 24. It is 24.
Give me
Oh
some
yeah,
skin,
that's a
Steve.
-3. Sorry, I thought that was a -2.
24.
Hey, Trent, sorry. I thought that was
Are you good,
-2.
man?
I'm with Trey. I'm with Trey.
It's -24. It's 24.
Nope, 24.
24.
It's gotta be
24.
It's definitely 24.
We'll see if the boys are right. No.
No.
Oh, that's the exception.
So this one's a little different because it's at -1, and if you go over to -1 and the f of -1, it's 8.
What? What are you?
How do we get 12?
Go back. Do it again.
Whoa.
Explain to me how you got that.
Yeah, this is the exception.
Wait, did they just take the 2 on the bottom, multiply by each other?
Yeah.
Oh,
Yes.
so if there's a -1 on the bottom, then there's another -1, then you just take the 2, right?
Yeah. So if it doesn't
If
switch
you have
columns,
if you-
just take
It doesn't switch columns, so you take the 2 on the bottom.
Yeah. It doesn't, but there's a -3 on the bottom, so the 1 has to be before it, right? Or does the -3, or does the one when it switch columns
Another
have to be a
problem.
GX or an HX, or can it be a prime? Kind of catch
So yeah, because see, this didn't switch, so you multiply these two together because
Can we do one more?
Oh wait, no.
let's do another one. Okay, so h capital H of g of h of x. So at 1,
9.
you go over to h of x of 2. You go 2.
It's 9. It's got to be 9. It's 9.
Is it 9 or is it negative 5?
9. It's 9.
Because it's the inside with that number they give you and the outside of the number that you
You
find.
know what? I think we all have it now.
Okay, so we're good? Yep. All right, let's go back to this.
If you're back, I got a good one to solve. We all got it.
No. Nice, but no. Okay, arctan of 2x is 1 over 1 plus x squared, right? Of 2x. So x squared is 2x, so it's 1 over 1 plus 2x squared times the first derivative of 2x, which is 2 on top. Okay? And then you stick a negative 2 in, so you get 8 here. So it's 2 ninths. Because 1 plus 8 is 9, 2 ninths. Okay? Here's the inverse is 1. Whoa.
How do you get 8 for 2x squared?
You're sticking a negative 2 in.
So then it's negative 4. The negative 4 squared should be
16, which is 1/8. Oh, 2/17. There we go. 2/17. We got there. All right. Inverse functions. So this is 1 over f prime of x, basically, after we do the... So you go negative 2 over 2g, and that's 5. So you use the g column. You go to f prime of x, and you go 1 over that. So 1 over negative 1/2 is negative 2. That's the inverse. Okay? This derivative is 7e to the x, where it's 4. So the first derivative of this is 7e to the x. And then if you stick in the 4, it's 7e to the 4th. Because e to the x is just doesn't change. Okay? This one we just got done doing. Do we need to go over this? Okay. This is 3x cubed plus 2y equals 0. It's the first derivative, but you need a dy dx here. 3x squared. Thank you, Makira. So then 2y equals negative 3x squared. And divide by 2y. So dy dx equals negative 3x squared over 2y. Okay. Then we take the derivative of that. So the derivative of that would be 2y times negative 6x minus negative 3x squared times 2 dy dx all over 2y squared. So it's negative 12xy plus or minus, let's go plus 6x squared times dy dx, which is negative 3x squared over 2y, all over 4y squared. And then you plug the numbers in.
What about the
Why
2?
4y squared?
What about the 2 and d by dx?
2 times negative 3x is 6. 2 times 3 is 6. I took these times each other. 2y squared is 4y squared. 2 squared is 4. Y times y is y squared. So it's 4y squared. I squared the bottom.
Could I just keep it?
You could keep it as 2y squared. Okay? Then you stick the 2 and the 4 in. So negative 12 times 2 times 4 plus 6 times 2 squared times negative 3 times 2 squared over 2 times 4 over 4 times 4 squared. So this is negative 96 plus negative, so this is 24 divided by 8, which is 3. Negative 9 times 4 is negative 36 over 64. Choni, this is one we did just a little bit ago. Negative 132 over 64. Right?
Yep. So couldn't you have just done the simplification little thing?
Yeah, could have.
This is a good
Would that have given you any advantage whatsoever?
Divide them both by 4. Right? Wait.
Yeah.
That goes, 4 goes into there, right?
132 divided by 4 is 33.
Oh. I thought you said 32. I thought you said 32. Negative 33 over 16. Yep. That should be the answer. Okay. Could this be a composite function? Yes. The inner function is square root of x. The outer function is log. Okay. Something that's like it would be like the log of x times 4x. Is that a composite function? No. No, that's a product rule problem. Okay, to do this would be
Quotient rule then, chain rule.
quotient rule, chain rule. Because you do the chain rule because the 3x is inside there. Quotient rule, chain rule. Oh, I don't have. Okay, Liv, let's do another one of them. What would that be? Chain.
Chain.
No, I got it for sure.
Okay.
Why can't it be? Why can't the other one be chain then?
It's not an option.
Could it be? You have to know.
You kind of have to do quotient first in this case, yeah. All right, this one. To do this one, people forget that you have to do the what to this first part. Product rule. Okay? So it's 2x times the first derivative of y, which is dy dx, plus y times the first derivative of 2x, which is 2, plus 3x squared minus 6y dy dx equals 0. Okay?
These ones are fun.
So 2x dy dx minus 6y dy dx equals negative 2y minus 3x squared. And you divide by 2x minus 6y.
Does it matter?
You have to factor it out and then divide, but I'm just doing that in one step to save time.
Does it matter what position you subtract the two?
No,
ones?
because they're both negative.
Okay.
Okay? So the bottom is 2x minus 6y. The top, if you factor out a negative 1, it'd be a. All right, Jacob tried this.
Well, he shouldn't have.
Here's his work. Step 1. To take the derivative, you take both of them. Derivative of that is that, derivative of that is that. So putting it all together, he took both derivatives at the same time. What's his mistake? Step 2, he didn't use the correct product rule. Okay? How could you rewrite this to make it differentiating just using the power rule? Distribute the x right at the start. Distribute the x and life is easy. Sine to the 7th of x. We rewrite it as sine of x to the 7th power. So it'd be
Uh,
7 sine of x to the 6th power times the first derivative of what's on the inside. That's a chain rule. It's an obvious D. Is that it? All right, let's get after it.
Yes, sir. Check this one. That's my last one.
This is your last one.
Yeah, this is my second time taking
Where are we at?
it. Right there.
Ah, you write yours differently. All right.
Why?
Arc cosine. So it's
-1
-1 over the square root
1 minus u squared.
1 minus
This should be
negative x over 5 squared times a negative 1/5 on the outside.
Yeah.
Right?
Yep.
So if we square this, well, we can put a 2 in right now, right?
Yep, x squared over 25. Oh,
Put the
we can just put the 2 in right away,
Right.
can't we?
So it's -1 times negative 1/5 over 1 minus 4 25ths, right?
Square root of 1.
All right, here we go. Boom, boom. Hey, sorry. Unit test, boom. Assign
How many questions?
14.
to next Monday. There's only 14, so you should be able to get it done today. So it's 1/5 over 25 minus 4 is the square root of 21 25ths, which is square root of 21 over 5. So it's 1 over the square root of 21.
That's what I got. Square 1 divided by square root. I would love it.